So yesterday we were talking about the interest formula for savings accounts, that kind of thing. And we came up with this formula. A of T is equal to either A or P. I'm going to use P. That's just what I'm comfortable with. If you do help me solve this or something like that, or if you're an example, they're going to probably put an A there, but it doesn't matter. A and P are the same thing. And then we said 1 plus R raised to the T. Okay? That is, I don't want to call it simple interest because it's a little bit more than that. But that is what you would find in your account if you were to never touch it again and the bank just lets it sit there for X amount of years. Okay? T is going to be in years. Okay? So if they say you're going to do this for 6 months, you need to make that 0.5. Does that make sense? Okay? So maybe we should write this stuff down. P is principal, okay, or the initial investment. R is the interest rate. Okay, make sure that you use a decimal version of that. And T is time. It's always going to be in years. Okay, now what happens is that banks can say, if I'm going to leave this money in there for 1 year or 2 years or 3 years, the only thing that is earning me more interest is the original money that I put in. Okay? So if I leave my money in there for, let's say, 10 years. Okay, let's go back to, I think, the example we did yesterday, or an example similar to yesterday. Let's say our principal is $1,000. Okay. Let's say our interest rate, let's just say 3%. And now let's say the time that we leave it in there is 10 years. Okay. So if I plug that stuff into my formula, and you're going to want to use Desmos with these. It's going to be the easiest thing for you to do. I'm going to say principal is 1,000. 1 plus my interest rate of 0.03, and I'll raise that to the 10. Okay, so that gives me $1,343.91 at the end of 10 years. Okay, as that 10 years is progressing, though, after the first year, I've earned some money, haven't I? Even after the first day, that $1,000 has earned me some money on that interest. Okay, it would be nice if maybe, let's just say after the first year, after a first year, this would be the amount of interest made. Does that make sense? So it would be nice if I could put that $30 back into my account as the starting value and let that $30 also add interest. Does that make sense? Okay, so it would be nice to be able, in a year 2, instead of taking $1,000 times 1.03 in year 2 and making another $30, is to take the 1,030 now that I have in my account and multiply that by 1.03 and make about, $30.90. Does that make sense? In the second year, okay? And then in the third year, let that money be added back in, so that 90 cents being added back in, and make more money that way, okay? So that's called compound interest, okay? Compound interest. And let me see, I might have a quick video to show this explanation. All right.
On the interest that has accumulated over time. It is easier to think of compound interest as interest on interest. And to understand compound interest, let's first look at simple interest, the interest earned on the original principal only. Suppose you deposit $10,000 into a high-interest savings account at a 5% simple interest rate for 3 years. The interest you earn each year is 5% times $10,000, which equals $500. For a total of $50,000
That kind of makes sense. In the second year, you make a little bit more.
You earn 5% interest on $11,025. $10,000 plus 500 year one interest plus 525 year two interest, or an interest payment of $551.25. In total, you earn $1,576.25 in interest over 3 years with compounding interest versus $1,500 with simple interest, a difference of $76.25. The effect of compounding becomes especially powerful over longer time periods as the amount of earned interest becomes larger and larger.
Okay, when we look at that curve right there, what curve?
Earned interest becomes larger.
What curve are we showing here? What have we been working on? This graph is showing an exponential curve, isn't it? Okay. So basically what we're talking about here when we talk about compound interest is that your interest is going to accrue interest. Okay. The money you made is going to immediately, when I say immediately, that word might be relative, but it's going to soon make you more money as well. Okay. And it's a marketing thing for banks. Okay. So Bank A might say, we can give you a 3% interest rate and compound annually. So at the end of every year, that amount that is in your account at the end of the year gets rolled over and becomes the new principal for year two. They can say we could do that once a year. Okay. Bank 2 might say we can't do 3%. We can do 2.8. But we will compound every 6 months. So basically your principal regenerates or restarts every half year. Does that make sense? Okay. And then you have to decide as a consumer, well, which one's best for me? Okay. So that's going to augment our formula a little bit. Okay. And I don't want to get into great detail. This is really right here. A lot of the formula, okay, if you want to read that on your own, it explains the algebra behind this formula. Okay. But our formula for compound interest is this, okay? The amount after a time t, okay? The amount after a time t is equal to the principal times 1 plus the interest rate divided by n raised to the nt. So P is the principal, R is the interest rate per year, remember that's in decimal format, N is the number of times interest is compounded per year. T is the number of years. So R is our interest rate. So if I were to get rid of the N, so if I hide that and I hide it here, that's exactly the formula we had yesterday, right? P times 1 plus R raised to the T, okay? But because they're going to compound this throughout a year multiple times, so maybe let's just say that our interest rate is 3%. Okay, like the last question said 3%. And let's say that I compound, so I'm going to say N is 2. So I compound semi-annually is how they will present that number 2 to you, which means you start on January 1st with a principal, and then July 1st it rolls over. Does that make sense? Okay, that'd be the 6-month mark. What we're doing there is they're saying that you are not going to accrue the entire 3% in that first 6 months. You're only going to accrue, because we're compounding it twice, half of that 3% in that first 6 months. And in the second 6 months, you'll get the second half. Does that make sense? So that's why we divide by N here. Okay? We divide by N right here to our interest rate, because we don't get that whole thing all at once, okay, in one compound session. Because this is, it never says it in the problems, but it's an APR, an annual percentage rate, okay? So your R is always provided as an annual value, and if we're going to do things semi-annually or quarterly or whatever, we have to divide that by usually 2 or sometimes 4, sometimes 12, depending on the duration of compounds, okay? Then we have to raise that to the NT, because ultimately then what we're doing is because we're generating more, basically we're rolling our money over, we have basically, we're repeating the process and multiplying it enough by itself that we have to raise the NT to make this kind of late. I don't want to get into the actual proof of this. Can get a little bit messy with our algebra, okay? But we raise it to the NT. All right. Now, what I want to demonstrate with you guys, if you can, a lot of these questions are going to be, here is a principal, here's an interest rate, here's a number of compounds, and we're going to keep it in there for 5 years, okay? So they're going to give you all these values, all right? And this is, again, hopefully I've demonstrated with you guys the benefit of Desmos, okay? I'm going to open up Desmos, all right? I'm going to type in A equals, actually I'm just going to go P times 1 plus R divided by N raised to the NT. I'm going to type in that formula, okay? Because now, because all these questions are very similar. They're going to give you a principal. They're going to give you a rate. They're going to give you a compound. They'll give you a time. So if we can type those things, we can say P equals 1,000 in this question, okay? Figure out what R is in the question. And type those in Desmos, it will automatically generate the value for me. Does that make sense? If you ever go online and, like, Google, like, I think we're doing it yesterday, looking for mortgage calculators, or looking for a car payment calculator or whatever, this is really what those calculators are developed with in the background, okay? They're not using Desmos, but basically they're saying, okay, in this box that somebody is putting the cost of their car, maybe that's P, or they're putting the amount of money that they're putting into their mortgage, that's P. And then it'll gather that information from the user, and it'll run it through a formula like this, okay? So my suggestion to you on your homework, use this thing. It's going to save you a lot of time, okay? So what I'm going to do is say a sum that is invested, so that's my initial amount, so I'm going to hit P, and I define it as 1,000, okay? Now this box, or this warning symbol won't go away until I tell the calculator what I want R, N, and T to be, okay? So I keep going through. It says an interest rate of 12% per year, so R is 0.12, okay? It's a crazy interest rate, all right, for savings, but that's actually a very good interest rate if I'm on a credit card, okay? Just find the month, find the amount in the account after 3 years if interest is compounded annually, okay? So I know T is going to be 3 years. Is that okay with everybody? Okay, T, remember, is years, and it's always, if they would say leave it in for like 36 months or something like that, I would have to change 36 into 3 years. Just be careful with that type of thing. But now it says compounded annually, okay? So compounding annually, these are some key terms that you're going to see in your homework, and these are the numbers that correlate to those words. Annual means once a year, okay? Semi-annually means twice a year. Quarterly, 4 times a year. Monthly, obviously we got 12 months, right? Daily, and you would have to maybe investigate what a bank is going to use, because we know that there's not always 365. There's actually 364.25 days in a year, right? It's a leap year. So there's some maybe fluctuation in some banking systems that number might not be 365 exactly, okay? If they say biweekly, does anybody know how many we mean when we say biweekly? That's every other week. So in a year, that would be how many times? Careful. It's close. It's very close. 26. And weekly would be 52. So yeah, so and yours would be 2. So those are just some key vocabulary terms that then we can convert over to a number. Okay? Yes? No? No question? All right. So when it says in this one, compounded annually, so I'm going to let n equal 1 for annually, and it says I will have $1,404.93. Is that okay? Okay. So 1,404.93 if I go semi-annually. Okay. Now, if I didn't compound this thing at all, okay, so let's say that n was gone, and I didn't compound at all, I still get the same result, right? Okay. So semi-annual, or not, sorry, not annually compounding is the exact same thing we were doing yesterday. Okay. Basically, your money's only going to roll over once a year. Okay. If we go semi-annually, okay, so that means the n value goes to 2. So I'll just come down here and put a 2 there. If I was doing this on my handheld calculator, I would have to retype the entire expression with a 2 for the n value. Does that make sense? Put on Desmos, I change one thing, and it evaluates. So 1418.52. 1418.52. Did I make more money by the bank compounding it twice a year? Yeah. And basically what happened, it sat in there 3 years. Basically, this rolled over, my money rolled over 6 times. My interest, gained interest, essentially 6 times. Okay? And that accrued to about, 13, 14 extra dollars. Okay? If they do quarterly, okay, so quarterly would be every 3 months. But that means n, then it's 4. 1425.76. 1425.76. Okay, made more money, right? My money rolled itself over 12 times, or sorry, yeah, it'd be 12 times. Okay, 4 times 3 in that duration of 3 years. Monthly, now my money is going to roll itself over 36 times. So n, when it's monthly, n is 12. 1430.77. 1430.77. Okay. Now, what I want you guys to see here is the difference in these values as we move on to more compounds. Early on, the difference in those two was about $13, $14, right? What's the difference between these two? About $7, right? What's the difference between those two? About 5. What's the pattern? It's getting smaller. I'm making more money, but the change in more compounds is getting lesser and lesser. Okay. If I go daily, so daily would be n being 365. I get 1433.24. 1433.24. And now the difference between monthly to daily, that was only $3, right? Okay. Now I want to just investigate this a little bit more with you and to kind of hopefully prove a point to you. If we look at, might be easier to do it this way. Let's go to another one of these. Yeah. All right. All I want to do here is just be able to compare two things. So these are identical things, except for n is going to change here now from 365. So that's compounding it daily. Let's say we compound it twice a day. So n would be 365 times 2. Does that make sense? Oh, I didn't put t in here. T is 3. Okay. So if I compounded it daily, I made after 3 years, I would have made $1,433.24. If I compound it twice a day for 3 years, I make really the same amount of money, right? I make about 5 more pennies, right? 5 more cents. Okay. Let's say that we compound it instead of twice a day. Let's say that we compound it every hour. Okay. So if I compound it every hour, what do I multiply 365 by? 24. Okay. So now, as I look at those, okay, so previously we had 365 times 2 there. See how many more times I've compounded? Here I compounded 730 times. Now I'm compounding it 8,760 times in a year. Okay? More than 8,000 more compounds, and I only get 4 to 5 more pennies, right? Does that make sense? What if I compounded it every minute? So if this was 365 times 24, what would I need to multiply this by to go every minute? Because that's compounding every hour. So multiply by 60, and it would tell me to compound every minute. Okay? Is there much of a difference between that number right there and that number right there? No. Okay? It's just, it's less than half a cent. Okay? But look at how many more times I compounded. Okay? Basically compounded more than 500,000 times more than what I did previously, but it only generated about half a penny. Okay? If I multiply this by 60 again, that is compounding every second. Does that make sense? Okay? So this would have been compounding right here, compounding every hour. This is compounding every second. So now, during the duration of time, I'm going to compound 31 million times in comparison to 500,000 times. And if we look at the difference in the money, it's 0.329 on both of them. It's 1 1,000th, okay, difference. Okay, not a big difference there. Does that make sense? So what we're saying here is eventually, the more that you roll your money over, the more that they compound it, you start to plateau. Okay, it's always better to have more compounds, and it's actually best to do something called continuously compound something. Okay, so what continuously compounding means, there is a number that you guys are not aware of. I don't think we haven't. Well, at least we haven't talked about it. You guys know the number E, the natural number. Okay, the natural number is like pi. Okay, so if I put in E here, see how it just kicks out this number right here? Okay, so E is an irrational number. See, it's kind of like pi, right? Okay, but it's 2.7 is the natural number. Okay, what we find out, and it's the letter E because the guy that found it, his name was Leonard Euler, Euhler, and his last name starts with E. So it's named, essentially titled, or the notation is named after him. He found out that as we start looking at a particular function, which deals directly with this right here, is that eventually when n gets really, really big right here, okay, or ultimately when that exponent right there gets really, really, really big, what happens is that this quantity eventually turns into that 2.78 number. Okay, turns into E. So, if you take my college algebra class at some point, we actually go through the proof of that. But if they ever say we are compounding something continuously, what that means to us is that we're going to drag this formula into the problem. Okay, P is still the principal, R is still the interest rate, and T is still time in years. Okay. What I want to look at, though, real quick with you is if we use that formula. So let's say that this scenario, would you guys agree that if I'm if I'm compounding, what we say, that was compounding every second, right? That's almost, once the number rolls over, once my money rolls over, that second expires, it rolls over again. That second expires, it rolls over again, right? That's pretty quick rolling over, right? Okay? But in regards to continuously rolling over, that is very slow, because continuously rolling over is like on the nanosecond or micro or picosecond. Does that make sense? Okay? The moment that we start rolling over, we should start rolling over again before it's even calculated. So that idea is this formula here, P times E raised to the RT, okay? And that number right there will always be bigger than that number right there, okay? If I use the same interest rate and I use the same time period, okay, exactly the same principle as well, compounding continuously will always generate you more money. Does that make sense? Okay, so what happens? Banks will ask this type of question. So let's say that this is bank one over on the left. So let's say bank one over here, and let's say bank two over here. Let's say bank one says, we can offer you an interest rate of, let's say, 3%. Okay. And we're going to keep this in it for 3 years, okay? Just as long as this 3 years is the same as the 3 years over here. And they're going to say, well, we can compound it. Let's just go monthly. So we get 12 compounds, okay? You're going to make 1,000, or you're going to make $94 off that, and in total you'll have $1,094.51 at the end of that 3 years. Does that make sense? Okay. Bank two says, well, we can't offer a 3% interest rate. 3% is way too much for us. Okay. But maybe they can offer 2.8. Okay. Now, because we're compounding this, oh, I put the wrong number. T was 3. R was 2.8. Okay? So I don't need N in this anymore. In that case, because the interest rate was different, we see that in bank two, I'm not going to make as much money, even though that was continuously compounded. Does that make sense? Okay? So it's a marketing thing for banks. Okay? Interest rates are things that people like look at real well, and those are like the key marketing quantities that they post a lot of times. Okay? Because it's what people understand the most. But if a bank can't match an interest rate, maybe they can do better for you in regards to the amount of times they compound. Okay? Let's say that, so if we go 0.28, that doesn't match that. I lose about, $7 by 0.2. Maybe they can go 0.29 or 0.029. Okay? Still not equating that. Maybe bank one can only give me compound quarterly. Okay? Or maybe they can only compound semi-annually. And at some point, we'll have to make the decision, okay, based off of how many compounds can they give me and what's the interest rate on what bank is the best. Does that make sense to everybody? Okay. But if everything is equal, everything across the board is equal, interest rates are the same, time is the same, principal is the same, compound interest continuously is always better because that is now greater than that one, right? Does that make sense to everybody? So as you're doing your homework, I don't know how many of these are in it, compounding continuously, but I think that's a topic that is important to talk about here. In your homework, a lot of your questions will give you something like this, where it says, here's the sum that you're going to invest, here's the duration of time and the interest rate that we're providing, fill in the box for what amount you're going to have after 1 year, after 2 years, after 3 years, or annually, semi-annually, quarterly, that kind of thing. Okay? Does anybody have questions on this? All right, so these are all this is math. People always ask, what am I going to use this math for? This is mathematics that you can take outside of this class and actually apply to real world situations. Okay, and I think it's probably one of those things that is probably going to be most important to you. Okay, would you guys think that making money, saving money, earning money is going to be important to you outside of school? Yeah. Okay. So hopefully this is something of benefit to us. So there's assignment. It's called 7.1, assignment 3. It's available tomorrow.